All right, next journey, we are going to jump into what's called quadratic functions. Okay, one of the big things that we want to get through here in this Algebra 2 course is being able to differentiate between different types of functions, being able to look at graphs, equations, tables, and know what we're talking about and transform them into the other ones that we don't know. So we finished up with linear, so now we got to jump into our next type of function, which is quadratic. How we know we have a quadratic function is that we look at the highest power, which here is 2, which is going to be what we talk about as the degree of my equation. Okay, so when we talk about second degree equations, we're talking about quadratic function. It has that special name. Okay, anytime we're looking at quadratic function, it needs to be in a form where I have y equals, or sometimes it might be 0 equals, but we're going to get all the stuff on the right side. So on the right side or on the left side, it could be that side too, but on the same side, I'm going to have my a x squared plus bx plus c. A, b, and c being my coefficients, c being my constant. Now, we'll talk about a lot of times as my leading coefficient when we get to some of our higher order functions. You know, whichever term helps me determine the degree of my function, its coefficient will be talked about as my leading coefficient. But more specifically, if I mention the word quadratic coefficient, that's my coefficient of my x squared piece. B is going to be my linear coefficient, because again, x to the first, we just finished up with y equal mx plus b. Okay, so that's my linear information, and c is my constant, the part without the variable. Okay, so one, we got to be able to recognize, is it a quadratic function or not? So what we're going to look at, and we're going to start with, is simply graphing quadratic functions. So a couple things. We always are going to talk about our higher order functions in terms of we have a parent function or a parent graph. Okay, so my parent equation, is simply f of x or y equals x squared. Okay, our parent graph is going to be nothing's been done to my function other than, you know, I'm raising it in this case to the second power. Okay, if we talk about absolute value, it'd be just y equals the absolute value of x. I haven't done anything to it, I haven't added, subtracted, multiplied, anything like that. Okay. And when we graph it, we get what we call a parabola. Okay, parabola. Quadratic function has a name for its graph, and it's kind of this U-shaped situation here. Okay. But that's what we're going to get when we graph these quadratic functions. Now, there's some special things about a quadratic function that we're going to identify every time we look at graphing these. Number one, we are going to find what's called an axis of symmetry. I'm going to goof up from time to time. I know I will, and that's what I'm going to tell you right now. I'll also call it line of symmetry from time to time. And what it does, it divides or cuts our parabola in half, and we will be putting this on every one of our graphs. Okay, we're going to graph that. And what it does our symmetry idea. It cuts it in half, so if there's a point on one side of the line, there's a point the same distance on the other side. So if I looked at this point right here, that's 2 units away from my line of symmetry, there's going to be a point on the other side 2 units away. Here's one that's 1 unit away, so there's going to be one on the other side that's 1 unit away. Okay, and that's also going to help us in terms of plotting some of our points. Okay, another thing we're always going to find is our vertex. Okay, our vertex is that point where we change from going down to all of a sudden we change direction and start going up. If we flip or reflect this parabola over so it's upside down, okay, what's going to happen is now it's going to be a point where we go from getting bigger and bigger and bigger to now all of a sudden changing direction and going smaller and smaller and smaller. Okay, so in my parent graph, what we have is a vertex, and like they're saying here, at 0, 0, at my origin. And my axis of symmetry is right here, at x equals 0. Now, axis of symmetry, this is what I like to talk about as a line. We have to use an equation to identify. Okay, I can't just say it's at 3. I can't just say it's at -4. Those are points. Okay, we have to have a line, so it's going to be x equals. And that's why we spent some time with linear, because again, vertical lines are always x equals. Now, we may down the road also use a table And when we do get into our transformations later this year, one of the things about our table is you're going to have some points that we're going to use to help us transform. Now, we're talking about y equals x squared. So way back when you started dealing with graphing things, you'd put numbers in a table and go from there and plot those points. And it's kind of going to be the same thing. If I plug in -2, square it, -2 times itself is 4. If I take -1 and square it, -1 times -1 is +1. And these are going to be important points. And if you remember looking back at the graph, those points were on there. -2 was up here at 4. +2 was 4, because remember we talked about how that was 2 from the line of symmetry, and that's 2 from the line of symmetry. Okay, so those points may come into play eventually as we start doing some graphing. They may help some of you as we graph some of these, but we're going to do a process with one type of form right away and then go from there. All right, so what we're going to talk about this form as a little more often is what's called standard form again. Okay, we mentioned it with the linear situations when I had all my variable junk on one side and my constant on the other side. Now when we get to higher order functions, it's going to be y equals, okay, all the other junk. That's going to be our standard form. So one of the things that we always want to do when we graph a quadratic function is, number one, make sure it's in the proper form. Okay, make sure that what we have is my x squared piece first, then my x piece, then my constant. The other thing that's going to happen is sometimes this isn't going to be y, it's going to be 0. Okay, and so like I've talked about a few times, unfortunately we start with linear and beat that down so much that we always get x equals something. Well, now when we get higher order functions, we get everything on one side equal to 0. And so linear is actually the exception to the rule. And then what I want to do is I want to identify a, b, and c. Okay, so when I look at it, I want to know what a, b, and c are because I'm going to plug those into some formulas. So when I go up here to my function, again, a is my quadratic coefficient, so it's the one with the x squared. B is the piece that's with the linear, so it's with the x. C is the part that doesn't have a variable. Now, from there, what I'm going to do first is find my axis or my line of symmetry. And it's a pretty easy way to do that. And what we do is we take x, and that's going to be equal to the opposite of b all over 2a. And so I always tell people is to write that. X equals opposite of b. So the opposite of -8, +8. 2 times a, 2 times a is 2. 8 over 4, which is 2. If I write it this way, what I've done now is I've kept it in terms of an equation. I don't have to rewrite. There's my x equals 2. Okay. Always, always, always draw this on your graph. Okay. And I like to suggest using a highlighter because then it's easy to see where your line of symmetry is. Okay. Now, one of the things, if you go back to this situation, your vertex is on the graph, okay? It's on your parabola. And again, remember the idea when I graph something, those points on the line or the curve that I'm drawing make my equation true. So what I can do now to find my vertex, okay, is I can plug an x value in, solve it for y, okay? And even if it's a 0, what I can do is change that to a y to get an ordered pair. So what I want to do here now is I want to find out what is y when I take a, or actually go back to my original equation way up here, 2x squared. Okay, and again, we've talked about when we plug these things in, put the parentheses wherever I see my x, so -8 times x plus 6, and then plug the 2 in for that x. Now what I'm really going to stress is that we want to start making use of our calculators more and more to help us find those y values a little more quickly and a little more accurately, because we may run into fractions from time to time. So I'm going to type it in again exactly as I see it. So I get a y value of -2. Okay. So what that tells me my vertex is, and a lot of times I'll put this v in front representing vertex. When I use x equals 2, I got y to be -2. So I'm going to plot that point on my line of symmetry. Your vertex is always on the line of symmetry. That's a great thing. All right, now we need to find 4 more points. One of the easiest ones that we can find is your y-intercept. Because your y-intercept is simply at 0 and then your constant. My constant here being 6. Reason being, go back up to my function. If I plug in 0 for x again, that goes to 0, that goes to 0. What's left? The 6. Okay, so that's a very easy point to find. And so I'm going to go up here to 0, 6. 1, 2, 3, 4. Now, I'm going to use that symmetry idea. 2 steps away from the axis, so I go 2 more steps the other direction, and there's another point. Okay. I probably could get by with just using those 3 points, but I'd like to find, 5, because then it makes my graph a little better. Sometimes they're not going to fit on the graph, and so we get by with 3, but we'd like to try and find 5. Now, the other way I can do is I'm going to use another value of x that's close to my axis of symmetry. Okay, so what I'm talking about, somewhere on my x-axis here, I want to find an x value that I haven't used, say like x equals 3 or x equals 1, and plug that into my original function. Okay, and so if I go back up here, I'm going to use the x equals 3. I want to know what is y equals going to give me when I plug in 3 for x. Okay. And again, here's another reason why it's going to be important that we start dealing with using my calculator. Okay, because I want to minimize points and places where I make errors. Okay, and so what I get is 0. Okay. And then again, what I'm going to do is use that idea of symmetry. So since it's 1 step from the axis of symmetry, I'm going to go 1 step in the axis of symmetry, the other direction of the axis of symmetry, and now I can draw my curve. And again, it's a curve. It is not just plain dot to dot. All right, so I'm going to quickly go through one other example here since my time's running short. You can always come back and replay this one and look at what we're doing here again. The example I want to look at is a situation like this. Okay, y equals 4x squared plus 1. I talked about getting y equal ax squared plus bx plus c. I'm missing a piece here. I'm missing my x piece. And the only reason I'm missing my x piece is because I made it go away. And again, how we do that was by multiplying it by 0. So if I'm missing a piece, I want to put it in as a 0. Okay. So when I get my a, b, and c, in this case, a is 4, b is 0, c is 1. So my axis of symmetry, x equals the opposite of b. Opposite of 0 is 0. 2 times a, 2 times 4. Well, anytime you take 0 and divide it by something, you're still going to get 0. So I'm going to add in my line of symmetry, which in this case happens to be simply my y-axis. Okay. Now when I plug in 0 to find my vertex again, remember the nice thing that happens. 0 squared is 0 times 4 is 0. I get my vertex at 0, 1. Now, this case, I've already found my y-intercept. Okay, so I have to do a little more work. Okay, and so what I'm going to do is I'm going to check when x equals 1 and when x equals 2. Okay, because if I find when x equals 1, I can reflect it to get another point. Same thing with 2, so there'll be my 5 points. So when I plug in 1, okay, just quickly, 4 times 1, 1 squared is 1 times 4 is 4, plus that 1 is 5. So I get a point at 1, 5. Reflect it over. When I plug in 2, okay, I'm going to get 4, I'm going to get 16, I'm going to get 17. Doesn't fit. So in this case, I'm going to have to just get by with those 3 points. All right, you're probably going to need to rewatch this video a couple times, especially with that one example, and hopefully that'll help you here. The big piece on this one is that b is 0. All right, good luck.